part. uh so we'll do this in each layer. How what we currently understand: surface, what's missing, errors of omission, what will block you later if it stays fuzzy, no flop, no, just trust it. Part 1: what the static getter really is, not the buzzwords. The code you've seen: class Supabase config, open semi-curly bracket, next line static Supabase client, get client equal right arrow, Supabase.instant.client semicolon closing. You've been told easy access, single instance, singleton pattern, or single instance of node. That's true but shallow. Let's rebuild it from first principles. First, what static means at the machine or runtime level. Static does not mean global variable. It means this member belongs to the class itself, not to any object instance. So when you're creating a class, there's a member inside it, right? Not to any object instance. So this Supabase config.client here, this class does not require Supabase config object. There's no object allocation here. It ties back to earlier CPDU discussions you asked before about program counter, memory, stack versus heap. A static member lives in the program's loaded class metadata, not on the stock. So it's not on the stock provided to the user space. It lives in the program's loaded class metadata. So that's what the class loads, and that static are provided there, not per object on the heap. So it's not on the stock and not allocated as an object via heap. So accessing a static getter is closer to jump to a known address and return a value, which is like the metadata in that program. That's why it's fast and deterministic. What a getter really is: this static Supabase client get client equal right arrow. That is not a field. It is a syntax sugar for static Supabase client. Then client open and close parenthesis, open semi-curly bracket, return. Key implication: this matters later. It runs code every time you access it. So it's kind of like an object because there's a client and then it will return something. It compute, validate, or redirect access. So this is where the object and computation happens, not in the class level. So as you can see, inside the class, you don't have anything yet. It's just a metadata in the program. You don't allocate. But here, this is where you allocate and then recompute based on values. You can change the implementation without changing call sites. So Supabase config.client looks like a variable but behaves like a function. So Supabase config.client, like when you instantiate this, it looks like a variable, but it returns a function. It behaves like a function. So this connects. This is how the memoization happened. To memoization: referential transparency, hiding implementation details. Why this is not creating a singleton? Here's the subtle but critical correction. Your static getter is not the singleton. Supabase already is the singleton. So that static getter that kind of like provide the function and memoization is not the singleton. The Supabase is what provides the singleton. This line, Supabase.instance.client, is where the singleton actually lives. So this Supabase instance, that client here is where the singleton actually live, and that's a Supabase more than it is Dart. Your code is doing indirection, not instantation. So the real pattern is you have Supabase SDK singleton. Your application code to static getter, which is where's the static there? Here, the static Supabase get client. The application code to static getter to Supabase SDK singleton, which is that Supabase.instance.client. Why this matters? You are not responsible for lifecycle. You are centralizing access, or you're centralizing access to the Supabase. So you're not responsible for that lifecycle, and then you're preventing dependency sprawl or other like affecting the memorization of your output, because again this Supabase config.client behaves like looks like a variable but behaves like function, because this is connect to referential transparency. When you connect that, like the static Supabase get client, it's just a syntax for static Supabase client and then return. So it runs code every time you access it. This is where the recomputation happen. Now, why this matters for large system future you problem? If you don't understand this deeply, later you'll pass clients everywhere, or the Supabase config that client, like that function, you pass that everywhere, and then recomputes it everywhere. You will create multiple DB connections instead of centralizing it in Supabase SDK singleton that provides the centralized access, and then it will break testability and then create hidden coupling. The static getter is dependency control, not convenience. So this static getter here is like a dependency control, like making it having us avoid the multiple DB connections, but at the same time help us like control the dependency. So static getter first before our actual application code. So that's why we write that code which has the Supabase.client. Let me just check where it is in the code. So that's the first that we will create, Supabase_client that Dart. So import package Supabase_flutter slash Supabase_flutter that Dart. Then that's a single responsibility only configuration, static access for easy use throughout app, and environment variables for security. So the class Supabase config, open semicolon, so y string.environment, reasoning, secure configuration, different values per environment, learning, build time configuration versus runtime. As you can see, static const supabase equals string that from environment argument supabase URL semicolon next line static const supabase anon key equals string that from environment supabase underscore anon underscore key. Then y static getter reasoning easy access single instance. So that's learning singleton pattern with supabase. Then static supabase client get client equals supabase that instant that client closing semi-curly bracket. Then step 2, we will create the router.dart. Part 2, single source of truth for auth state diff version, your service understanding. Auth state means whether the user is logged in. That's incomplete. What auth state actually is, auth state is a compound state machine, not a boolean. It includes access token, refresh token, expiration time, user metadata, session validity, revocation status. Supabase tracks this internally and exposes derived views. So auth that current user, and then next line auth that on auth state change. So auth is authoritative server back state, not UI state. So it's not a US state. It's more of like a Supabase state. So what single source of truth really means? It means there exists exactly one place in the system that decide who is authenticated. In your app, that place is Supabase, that instance, that clients, that auth. So that's the purpose of this Supabase that client in Supabase that underscore client that dart. That maintains the authorization or the single source of truth, not widgets, not route logic, not local variables, not route logic, of course, and not widget, because we only write router underscore that and then auth underscore provider that dart and then path state after the Supabase that instance that client. So everything else must derive from it, never redefine it. Tie back to databases. This is the same reason you said earlier. Heavy logic should be explicit in SQL, not front end. Same principle, avoid duplication, avoid divergence, avoid race conditions. Error of omission you currently have, you sometimes think GoRouter is checking auth. No, GoRouter does not know auth. GoRouter queries the auth authority. So GoRouter does not know the implementation of auth. It queries the auth authority to be able to know if it will route it. That's why it has this precondition before it. This distinction is massive. So in route security, what's actually happening? Let's take this line by line mechanically. Final router is equal GoRouter, open parentheses. What does this mean? This does not navigate yet. So this builds routing state machine. So this is what will create that routing state machine. So that state that allows data flowing in your program. This is what allows it. So the initial location colon code / comma. So what is that? This is the requested route, not the final route. This is important. It runs before route resolution. The redirect function, this is the core redirect. So this redirect is actually what is the function. So it creates the object. So inside it is we have a function, and before the function we have the initial requested route. The function is pure, synchronous, deterministic. So think of it as input app state plus the requested route. So the current app state, whether it's like currently logged in, and then the requested route. So depending whether the user is logged in or logged out, will determine how it will be routed by this. So as you can see, this function will is deterministic, and it will determine how it will route depending on the user state. Then output is the allowed route. So that output is the allowed route. That's a pure function, because again, in function we have input, and then function will be applied in the output. That's a pure function, like your earlier discussion on functional graphs. Now final is login equals supabase that instance that client that auth that current user not equal to null. This is where networking does not happen. No asynchronous work happen here because it's synchronous. You are reading cache auth state already synchronized earlier. So this is how routes cache output or memoize output ties back to riverpad cache, supabase internal event handling, while to WebSocket to web memory. Final is going to login equals state that match location equal argument slash login semicolon. This is intent analysis, not navigation. You are asking what does the user want to do, and then the actual guard logic. So basically, you're asking for the parameters for the user, what it want to route inside your app, and then the actual guard logic. If not is login and not is going to login and not is going to register, then you will return the login first semicolon. So that's the precondition before you even route that inside your app. So this is not redirecting, it is rejected request before rejected requested route and propose a replacement. The router engine or the Grow router engine that you imported will discard the original route, resolve the new one, then third build widgets only for allowed paths, or in this case it's login if it's not currently logged in. This is why it's security by design, not UI hacks. Why routes are defined after redirect. Now routes colon argument dot dot dot. This is not cosmetic. Redirect is authorization precondition check. So that's where the redirect context comma state is, or that the actual function. Now the routes function are implementation details only used if access is granted. This mirrors firewalls rules to services, auth middleware to controllers, database RLS to queries. How this connects to everything you've learned? CPU and pipelines. Redirect is like branch prediction. You're kind of like predicting it. Early exit if it's not much, and then speculative execution cancellation. Because the user is already not logged in, therefore you're gonna execute it. You predicted that it's not logged in, and then you execute that. The user must log in first before it can go to the route. Now databases redirect is equal to row level security RLS at the app layer. So the redirect in terms of database is the RLS at the app layer, and the supabase RLS is equals to the authority at the data layer. Sorry, the row level security is the redirect we provided here in routes at the app layer. In supabase terms, the RLS is the RLS in the supabase defense in depth. Docs and riverpad auth state is a root node, because we need the user needs to be authenticated before it can access the route, and then everything else depends on it. Bad mental model auth affects navigation. Correct mental model. Navigation is a projection of auth state. It needs to be authenticated before it can navigate. Events and emit. Supabase emits auth changes. Token refreshes. So the supabase that we initiate earlier decide if it's authenticated, and then the route checks that, and then a token refresh if it's not. If it's already logged in, it just cache that token. So that's also how we, get this box of profile. Let's say they log out. Since the application in memory caches that token, it was not refreshed in the backend, you get that bug. So your app does not listen manually. It reads synchronized state. It reads synchronized state because it checks the Supabase underscore client first and the precondition of Go router, and then re-evaluates redirect if it's logged in. This is reactive, not imperative, and that's also what makes it synchronized. Part 5, subtle misunderstanding that will block you later. First, thinking static is equals to global mutable state. It leads to untestable code. So just because it's static doesn't mean that it's a global mutable state. It leads to hidden coupling. Static access is not equals static ownership. Second, thinking redirect is navigation. You'll put side effects there. You'll break determinism. You'll cause loops. Redirect must stay pure. Thinking auth is UI state. Sorry, thinking redirect is navigation. So redirect is the first code in Go router. That's not the actual navigation. If you do that, you'll put the side effects in the redirect. You'll break the determinism or synchronization, and you'll cause loops because you don't recompute. Redirect must stay pure. Thinking auth is UI state. If you do that, you'll cache it incorrectly. You'll find token refresh box from the database, and you'll duplicate authority. What is infrastructure state? Not widget state. So auth is in the high level. It's in the database are included date. That's why we started with Supabase underscore client. Fourth, thinking single source of truth is a slogan. It's not philosophy, it's conflict prevention. Two sources, two divergence, two bugs that look random. Part 6, why this satisfy your boss requirement? Your documentation show you understand why static access exists. You know where authority lives. You enforce preconditions before execution. You separate configuration, state, and behavior. You can explain decision, not just code. That's AA independent competence. Final sentence you should be able to say out loud. We use static getter to centralize access to infrastructure singletons. So the static getter is just a tool we use to centralize access to infrastructure singletons without owning lifecycle. Route guards to enforce auth preconditions declaratively before widget construction in a single authoritative auth state to prevent divergence across UI, navigation, and data layers.